Today we're going to work on 4.2, and it deals with exponents and radicals. So just as a review, 8 to the 4/3. How would you write that as a radical? Third root of 8 to the 4th. If you look at it this way, what is the third root of 8? 2 raised to the 4th would be 16. If you look at it this way, can 8 be split into 3 equal multiplications? 2 times 2 times 2, and how many of those 2's will be in the answer? 4 of them. So I put another 2 there, and I get 16. Okay. What if that 4/3 was negative? Nope. It turns the 8 into a 1/8. So 8 to the negative 4/3 is equivalent to 1/8 to the 4/3, and you would just get 1 over 16. So if you have a negative exponent, all you do is flip the base upside down. So if the base was 2 over 3, if you had 2 over 3 raised to a negative, then it would be 3 over 2 raised to the positive version. Okay? Let's look at a couple more properties of exponents. If I had x squared times, well, let's do plus x to the 3rd. Can I put those together? No, they're not like terms. Okay? What if I had x squared times x to the 3rd? That's x to the 5th, and the reasoning behind that is this is x times x plus x times x times x, and they don't mix, right? But on this one, I have x times x multiplied by x times x times x, so I just add up all the x's, and then I have 5 of them, right? What if I had x squared times x to the 3rd? Oh wait, we just did that one. Sorry. How about this? X squared to the 3rd. How do you raise an exponent to an exponent? You multiply. So, essentially, it says we have 3 copies of this. So XX, XX, and XX, which is x to the 6th. So what's the shortcut? So if you have an exponent raised to an exponent, you multiply. So x to the 4th to the 5th is x to the 20th. Got that? So whenever you raise an exponent to an exponent, you just multiply those 2 exponents together, which means they can actually switch sides. X to the 4th to the 5th is the same as x to the 5th to the 4th, which is kind of weird. So the exponents commute, which is a little bit strange. All right, so in 4.2, I'm going to work some of the even problems. Look at number 4. 12 squared to the 1/4. How would we solve that? Well, you multiply the 12 and the 1/4, and you get 2/4, which simplifies to be 1/2. So this is 12 to the 1/2. But the 1/2 power is really just the square root. So I take the square root of 12, and I factor it. 4 and 3, 2 and 2. Bring out a set of 2's. 2 root 3. So 12 squared to the 1/4 is equal to 2 root 3. Okay? Number 6. 7 over... Wow. Don't ask. 7 over 7 to the 1/3. So the bottom one is the third root of 7. But if I had x to the 5th over x to the 3rd, what would I do? Subtract the exponents. So if you multiply, you add the exponents. If you divide, you subtract the exponents. And I would get x to the 5th minus 3, which is really just x squared. So in this case, I want to do 7 to the 1 minus 1/3, which is 7 to the 2/3. So I'm not sure how they want that written, but it could be either one of those. Those are the same thing. 7 to the 2/3 or the 3rd root of 7 squared. No, it was blended with the 7 on the top. Yeah. Then well, if the bases are not the same, you can't put them together, but sometimes you can change the bases so that they are the same. If it was a 7 on top and a 6 on bottom, you're done for. But we're going to run into some where there is a way to change them and make them equal. Okay? But that won't happen for a little bit. All right, number 8. I have 9 to the 3rd over 6 to the 3rd raised to the negative 1/3. What should we do here? So this negative is going to flip the whole thing upside down. So 6 to the 3rd over 9 to the 3rd raised to the 1/3. Okay. Now how do you raise an exponent to an exponent? So I need to multiply both of those. And I get 6 raised to the 1 divided by 9 raised to the 1. Does everybody understand that? What if I did it a different way? What if I multiplied this in? I would get 9 to the negative 1 over 6 to the negative 1, which is that. Right. Because you would flip, right, you would just flip both of them. Does that make sense? You okay? Yeah. Where did you get stuck? Okay. All right, number 10. 5 to the 1/2. Nope, it's not. It's multiply by 5 to the negative 3/2 raised to the negative 1/4. If we have two bases that are the same and we multiply them, what do we do with the exponents? Add them. It's like x squared times x to the 3rd. You add the 2 and the 3 together. So what is 1/2 minus 3/2? Negative 2 over 2, which turns into negative 1. So we end up with 5 to the negative 1 times the negative 1, or raised to the negative 1/4. Should I flip? No, because when you flip 1, you're going to end up flipping again. So I want to multiply these together, and I get 5 raised to the 1/4, which could also be written as the 4th root of 5. Does that make sense? Okay, number 12. Now this is the one you were asking about. Well, I don't know if you were or not, but 49 to the 3/8 times 49 to the 7/8 over 7 to the 5/4. What should we do? Combine the top. When the bases are the same and you multiply, what do you do with the exponents? Add them. So that would be 3/8 plus 7/8 would be 49 to the 10/8, which simplifies to be 49 to the 5/4 over 7 to the 5/4. Is everybody okay with that? The base has to be the same. And think of it in terms of variables. If you get confused, write it out in variables. If it was x squared times y squared, would we mix them? No. So the bases have to be the same. And so the rules with variables are the same as the rules with numbers. So if you get confused, just think of them as variables. So now, if we thought of these as variables, we would have x to the 5/4 divided by y to the 5/4. Can you simplify that? No, but can the 49 be turned into a 7? Yes. How? Well, can 49 be represented using 7s? 7 squared. So we're going to do a little trick here. We're going to say that 49 is equal to 7 squared, and then just substitute. We're going to put it in there. So 7 squared raised to the 5/4 divided by 7 to the 5/4. Not quite. What do you do there? Multiply them. So 7 squared to the 5/4 becomes 7 to the 10/4, which simplifies to be 5/2. So I have 7 raised to the 5/2 divided by 7 to the 5/4. Now subtract them, right? If you have one base divided by another base, you just subtract the exponents. So what is 5/2 minus 5/4? What is 1/2 minus 1/4? What's 1/2 minus 1/4? 1/4. So what's 5/2 minus 5/4? 5/4. Right? This one is half as big as the top one. Right? 5/2 is twice as big as 5/4. So it takes two 5/4s to make one 5/2. And if you forget that, it's fine. Just do 5 divided by 2 minus 5 divided by 4, math fraction, and you'll get 5/4. So the answer is 7 to the 5/4, also known as the 4th root of 7 to the 5th. And that 5 can go on the inside or the outside. It doesn't matter. So if we had x squared times x to the 3rd, does the x change? No, it's not 2x raised to the whatever. It's just it'll be x to the 5th. Okay, so again, if you get confused, look at it in terms of variables. They have to be the same number or they don't mix. And if they are the same base, then they don't change. The exponent changes. The only way to change the 49 is to add, not to multiply. Okay? Because if I had x plus x plus x, do the x's change? Yeah, it turns into 3x. But if I have x squared times x to the 3rd times x to the 4th, do the x's change? No. It would just be x to the 24th. So in this step, we combined the exponents using addition because the bases were the same. And then we simplified. We ended up with this, and we want to simplify further, but the bases are different. And we realized that 49 can be written as 7, but it's 7 squared. So I changed the 49 into 7 squared, so it's 7 squared to the 5/4. Then I use the exponent rule. Exponent raised to an exponent is a multiply. And that gave me this. And then I have a 7 divided by a 7, so I subtract the exponents. 5/2 minus 5/4 is 5/4. And that's the answer, or you could put it in radical form. Wow, those are intense. Okay, number 14 says the third root of 16 times the third root of 32. Well, If the roots are the same, then I can multiply the insides. If it was a square root and a third root, it won't work. Okay? So I can say the third root of 16 times 32 is 512. But guess what? There's no sense in creating the 512. How come? Because I'm going to factor it anyway. I'm going to turn it into a 512. What does 512 factor into? 16 and 32. Right. So we might as well just factor both of them and then treat them as one number. So this is what I'm going to do. I'm going to pretend this isn't here, and I'm just going to extend that out. And I have 16 times 32. So 16 is just 2, 2, 2, and 2. And 32 is just 5 2s. What do I need in order to bring something out? 3 of something. So I have a set of 3, a set of 3, and a set of 3. What's on the outside? 8. And what's on the inside? Nothing. So that goes away. Is everybody okay with that? Number 16. 4th root of 8 times the 4th root of 8. I could multiply them and get 64, but then I need to factor it again. And since these roots are the same, I can get rid of that one and just treat it like a single root. 2, 2, and 2. 2, 2, and 2. I can bring out one set of 2s. And what's left on the inside? 4. Everybody got that? Okay. Oh. Do I want to do that? Well, no, it's a rule. Okay, I don't want to do that one. All right. Yeah, I don't want to do those. There's another rule for simplification that you need to know, but it's really not very practical. There will be a time later on when we'll need it. The only trouble is we only need it in a very specific instance. So instead of trying to teach you every application for this rule, which is what the assignment does, I'll just teach it to you when you need to know it later. Because it's kind of confusing and it can be a little bit hard. So we're going to skip to number 38. 38 says 8 times the 6th root of 5 minus 12 times the 6th root of 5. What do we do there? Negative 4 times the 6th root of 5. Yeah. It's like saying 8x minus 12x. It's a subtraction problem. So when it's a subtraction problem, do we mess with the exponents? No. But the exponents have to be the same or it doesn't work. So if it was 8 6th root of 5 and 12 5th root of 5, can we put them together? No, because the exponents don't match. So basically it's saying if we have 8 of these and we subtract 12 of the same things, then we're just 4 in the hole. Well, do we change the x's? No, it just becomes negative 4x. So did we change it to x squared? No. So we wouldn't change the square root. We're just counting. We started with 8 of something, and we lost 12 of something, so we're 4 in the hole. But the something didn't change. Right? The only way to change the something is to multiply. All right. 3 times 11 to the 1/4 plus, oh, no, I'm on the wrong problem. Sorry. 13 times 8 to the 3/4 minus 4 times 8 to the 3/4. The answer would be 9 times 8 to the 3/4. Can 8 be split into 4 equal multiplications? No. It can be split into 3, but not 4. Okay? So this would be the 4th root of 8 to the 3rd. We don't need to write it that way. But can I blend the 9 and the 8 together? The bases are different and the exponents are different. So it's like x to the 1st and y squared, where the bases are different and the exponents are different. Can we mix them? No. X to the 1st and y squared do not mix. So 9 times 8 to the 3/4 does not mix. You could write it this way. 9 times the 4th root of 8 to the 3rd. Oh, actually, in this case, we can. We can go further. Because this is actually 3/8. And each 8 is a series of 2's. So this one does go further. Well, it's 3/8. So yeah. We need 4 2's. So what would the answer be? So it would be 36 times the 4th root of the leftover would be 2. I'm glad I switched that. I wouldn't have noticed that otherwise. Okay. I brought out 2 2's. So I multiplied 9 by 2 to get 18, and then I multiplied it by 2 again to get 36. Okay, the next one's a little bit tricky. 27 square root of 6 minus, that's actually plus 7 square root of 150. Do those mix? No. 6 and 150 are different. So it's like saying 27x plus 7y. But I can try to simplify the 150. And that would give me 10 and 15, 5 and 2, 3 and 5. I can take out a 5. And then I have 27 root 6 plus 35 root 6. And now they do go together. So that would be 50, 62. Nope. Because remember, it's 27x plus 35x. It's going to be 62x. The x did not change. Okay. 5 to the 1/4 plus 6 times 405 to the 1/4. What should I do here? Let's convert it to radicals. 4th root of 5 plus 6 times the 4th root of 405. Well, 405 is 5 and, I don't know. Wait, yes I do. 81. Got it. And 81 is just 3, 3, 3, 3. Can I bring anything out? Set of 3's. So the 4th root of 5 plus 18, because those multiply by the 6, times the 4th root of, the leftover is right here, 5. So I have the 4th root of 5 plus 18 times the 4th root of 5, which turns into 19 times the 4th root. Tiana? 19 times the 4th root of, is it 5 or 25? It's 5. Good. Because it's like 1x plus 18x is just 19x. Yeah, if they're multiply problems, then you can change the exponents. If they're adding problems, we don't change the exponents. All right. Then you can do the same thing with variables. The 8th root of x to the 18th y to the 7th over x squared y to the negative 1. Can I make the inside simpler? What is x to the 18th over x squared? X to the 16th. And what do I do with this y to the negative 1? Flip it and turn it into y to the positive 1. So I'm going to put y to the first up there. And y to the 7th times y to the 1st is y to the 8th. And we're taking the 8th root, so I can take out all of the y's and bring out one group. And I can take out all of the x's and bring out two groups. So I end up with, is it 2x or x squared? So if we write them all out, 1, 2, 3, 4, 5, 6, 7, 8, there's one group, there's one group. This gets an x and this gets an x. So x squared y. That is the simplified version of this. Okay, so there's some of these I don't want you to do. 4.2, let's do 3 through 15 odd. And then 21. And then 37 through 69 odd. Let me double check. Oh, wait a minute. Oh no, that's good. 53 is okay. 61 is okay. 63. 63 is okay. Oh yeah, yeah, you should be fine. All right, good luck.